In 5.3, we're still working with the normal distribution. And what we're doing here is we're going to have a specific amount of area or of probability that we want to be in the tail end of the graph, and we're going to kind of work backwards from there and see what z-score corresponds to that specific area that we want. So for this example, let's say for some reason we wanted 0.3632 to be, we want to find out what the cutoff is, what the z-value is that marks the spot where to the left of that there's 0.3632. Or in terms of probability, what's the z-value that marks the cutoff where 0.3632% of our data lies to the left of that value? And so you can see from the answer here, the z-value is supposed to be negative 0.35. And I'm going to show you how to do that in Excel. And so here's the formula you'll want to use, norm.s.inv, which stands for inverse. And then in your parentheses, just enter the percentage, or the problem could phrase it as the area or the probability that is to the left hand of your cutoff mark. And when you type that in and put a percentage in there, Excel will give you back the z-value that corresponds to the cutoff spot, where anything to the left of that z-value, the probability of falling in that area is equal to whatever you typed into the Excel formula. And if we're doing right-hand probabilities, looking at the right-hand tail, we're actually going to use the same exact formula. So let me show that with these same numbers up here. If I wanted amount of area in my right-hand tail, or this probability in my right-hand tail, and I wanted to know what z-value is associated with that, it's going to be the opposite of whatever my answer is for the left-hand tail, because the normal distribution is symmetric. And so if this z-value gives a cutoff where there's this amount to the left, positive 0.35 is the cutoff where there's that amount to the right. And in Excel, doing a right-hand tail, you do the same exact formula. And if you want to make it give you the positive result, you can multiply it by -1, which changes your negative answer to a positive. So use the same formula, just make your answer positive, and you get the z-value that corresponds to that amount in the right-hand tail. So let's do this example here. If we wanted 10.75% or 0.1075 in the tail, I would go to Excel, norm.s.inverse 0.1075. And we'll round it to 2 decimals like they had. So Excel gives you back the left-hand z-value. And you can just say, well, I know it's going to be positive 1.24 for the right hand. Or you can make Excel show you that by multiplying by -1. And that gives you the positive 1.24, which is the cutoff for having this amount of area in the right-hand tail. So looking at the homework, if it's asking for the z-score that corresponds to a cumulative area of some area value, that's asking for a left-hand. And looking at the left-hand tail, what's the cutoff to have this much in a left-hand tail? And the first couple, that's what they're asking for. And then we get to the third question, it's asking about percentiles. And percentiles are just another way of referring to left-hand tails. So for example, the 48th percentile is the cutoff mark where 48% of the data is at that mark or below or to the left. So if you wanted to know the z-score that corresponds to the 48th percentile, I would come in here, it's left, percentiles are always left-hand, norm.s.inverse, and you just type in the percentile you're looking for. And it'll give you back the z-value, the z-score that is the cutoff mark where 48% of the data is to the left or below it. That's how you do percentiles, that same formula. 4 and 5 are also percentiles. 6, we're just looking at it with a picture, but it's asking the thing. What's that z-value that corresponds to a certain amount of area to the left of it? 7 is asking about a certain amount of area to the right, so use the technique we talked about. So here we have one that's an in-between, and I think the easiest way to do this is, again, just to focus on the tails. So by the symmetry of the normal distribution, we know that from the mean, there's 50% of the data to the left and 50% of the data is to the right. The mean's right in the middle. And so if we look at a picture like this where how it's presented here, let's just look at 1/2 at a time. These z-values are going to be exactly the same because we have symmetry and we're looking for the same amount to be on both sides of the middle. And so if there's 50% to the left and we want this much to be, on the right-hand side of our cutoff, then we need 50% minus that to see how much is in the tail. So let's do 50% minus 0.4798. So we'd come into Excel, 50% minus our value. So that gives us what percent we're looking for in the tail. So it's just like before now. We can use norm.s.inverse, and that's the percent we want in the tail. So when we hit enter, it gives us that z-value, that critical value that marks the cutoff part for having that much in the tail. And by symmetry, if it's the -1 here, you just make it positive and you have the right-hand z-value. Number 9 is just asking about a right-hand tail with that much in it. And number 10 here is asking us about an in-between again. So if we think of having, I'll do this example here, 82% in between two z-values. And so notice how the answer even shows us that we have symmetry here, that whatever our z-value is on the left, we're just going to make it positive to get our z-value on the right. So we want 82% right in the middle of the graph, and then the rest being in the tails. So 82%, how much does that leave in the tails? How much does that leave in the tails? You would come in here and do 100% minus 82, minus 0.82. There's 18% in the tails. Now think about this. 18% total is in the tails. You need to split that between the two tails. So divide that in half. There's 9% in each tail to make 18% total in the tails. So now you can just do the norm.s.inverse. We want to know what is the z-value, the critical value that marks 9% being in the tails. And I'll get that down to 2 decimal spots like they had, -1.34. And so that's the left-hand mark for 9%, and then the right-hand mark's positive 1.34. And so then altogether you have 18% in the tails, which means you have 82% in between those z-values. And for the final few problems, we take a little bit of a twist. Here we're looking for actual data values. So it gives us a mean, it gives us the standard deviation, and we want to know what actual height, what actual data value represents the 95th percentile. So again, we're looking for a value that marks the spot where there's 95% from that point to the left. But we're not looking for the z-value here, we're looking for the actual data value of the height of the person that marks the 95th percentile. And what you want to do in Excel for this is use the norm.inv formula. So here, instead of getting a z-value back, a z-score, we're actually going to get the actual data value that corresponds to the percentage we enter. And it's going to give us the left-hand value back. So with the data 95th percentile, then you enter the mean, then you enter the standard deviation. And when you hit enter, it gives us back the data value that corresponds to the cutoff spot where 95% of the data is at that value or to the left. And in Excel, my answer was different from this because I didn't use this mean and that standard deviation. I had used a different one, and you'll have a different one for your problems. So enter in what they are for a specific problem, and you'll get the data value that corresponds to the your specific problem. Now, for first quartile, a quarter is a fourth, 25%. So the first quartile is 0.25. the 0.25 percentile, the 25th percentile. So you want to enter 0.25 for the first quartile, the second one would be 0.5, the third quartile would be 0.75. So that's how you do the quartile ones. Very similar question for 12. And then with 13, we have what we're looking at, the same type of situation. We have a mean, we have a standard deviation, and we're looking for, in this case it says bags in the upper 4.5% are too heavy and must be repackaged. So upper or more than or right hand tail are too heavy. So now we're looking at a right hand situation. So we're trying to find what is the cutoff mark for having 4.5% in the right hand tail with this mean and this standard deviation. And so when we're doing a right hand tail for this, we want to use the same formula here in Excel, but instead of entering the exact percentage that's given, we want to do 1 minus that, and then enter the mean and the standard deviation. And the reason we have to do 1 minus is because this formula in Excel only gives left-hand probabilities. And so if you're doing, if you're trying to find 0.04% to the right, that's the same as finding this much to the left, 0.955, or 1 minus the part you want to be to the right. And so that's going to be the same cutoff value that marks this much to the left as it is the part we wanted to the right. So doing 1 minus our percentage gives Excel the input it needs because it is focusing on the left-hand tail. So you have to tell Excel how much should be in the left-hand tail in order to figure out the right hand. And so that wraps up number 13. And then to wrap up this video, I want to just point out that if we were trying to find what's the weight of bags, that only 4.5% of bags weigh less than this weight. So the light is 4.5%. We would use our left hand formula because we're doing a less than or to the left of, and we could just type in 4.5% directly. And what I just wanted to point out that those values are the same distance away from our mean, which is 29, and right in the middle of our distribution. And that's what we should expect because the normal distribution is symmetric. And I just showed it here. This value marking the cutoff spot, 4.5% of bags weigh less than this. It's that far below the mean. And this value marking the cutoff spot, 4.5% of bags weigh more than this, is the same distance above the mean. And so adjusting it so there are the same number of decimal spots, you can see that they're exactly the same. And please keep watching. Earlier in the video, I talked about using this formula for right hand, finding right hand z-values. The formula is correct. It's what you want to do. This is a little misleading here to say use the same formula but make it positive. I should say make it the opposite. So if it comes out negative using the formula, then you would make it positive. But if the z-value came back positive, then it would end up being negative, which multiplying by -1 accomplishes what I just said for you. But make sure you're making it the opposite. So for example, this problem right here, we're trying to find the z-value that marks 0.719 being to the right of it. So if I came into Excel, I would use norm.s.inverse 0.719. And that gives me a positive answer back. And so the correct answer for being to the right-hand tail would be the opposite of that. So -1 times my answer there. This is the z-value that marks having this much area to the right of it. And always think about your answer. This z-value is definitely to the left of our mean, so it definitely needs to be negative. So that could kind of be a hint that this answer is wrong. It doesn't need to be positive. It needs to be the negative of that because we're to the left of the mean. So use the same formula, but make it the opposite.